I'm very honored to introduce our today's lecture presenter, Dr. Lal, and I'm going to give a little bit introduction about where he's hailing from and what are the major things he received and overseen. And Dr. Lal retired from Alabama A&M University in 2007 after serving the university for 32 years as a professor of physics and the chair and eminent scholar of the Department of Physics. He obtained his master's and PhD in solid-state physics from Agra University in India in 1958 and 1963 respectively. And he completed his postdoctoral work from NASA MSFC as a resident postdoctoral associate of the National Academy of the Science and National Research Council. So that is how he came to US as a postdoc to work at NASA. And at MSFC, he performed pioneer work on the effects of radiation on thermal control coatings for Apollo and other spacecrafts. On the special recommendation by Dr. Von Braun, Dr. Lal's term as a postdoctoral associate was extended for Ray third year. And usually it doesn't happen, but because of his esteemed work, it was extended for third year. And in 1978, while at AMU, Dr. Lal was chosen by NASA as a principal investigator for a space shuttle experiment on the maiden flight of the Space Lab 3 mission in 1985. And he was one of the first university professors to be chosen for the experiment on the space shuttle and for the first time from A&M. And Dr. Lal was the principal investigator for the project from NASA's commercialization of the space program for 7 years. And I'm sure that I think he is the one who started the NSF RISE program, which is to enhance the doctoral program at physics department. And he's the one who initiated it, and I think that is how the PhD. I think our department has probably 72 PhDs right now. I think his contribution is a lot in doing that. And Dr. Lal's honors and awards relation, and in March 2007, the National Association for the Equal Opportunity in Higher Education, which is NAFEO, awarded Dr. Lal its Nobel Prize in Science, which is a very high honor in science. And today I'm very, very privileged to bring Dr. Lal to our department to give a talk on the research ethics. He is very, very, like a father person of the department, not only the department as a professional, as a person also. He's very nice, and I have known him for, I think, 6 years, and I'm very, very honored to introduce him today. Let's give the floor to Dr. Lal.
Thank you, Madhya, for very great introduction. I don't know whether I deserve all that or not, but
you do.
Yeah, but it has a contribution of lots of people. It just happened to be that I was in a very good department with good faculty. That's why I could do all that work. So I'm really honored to be here, and I'm so glad that I'm here with younger generation people and my colleagues. Dr. Goal and Dr. Mustafa and Qadbaja, they are all sitting here to listen whether I will talk. See, research off.
Yeah, he just wants to record your presentation, so we just want.
We can be good.
Light.
I mean, that'll be fun. Maybe one light.
Maybe one is good.
Okay. I think yeah. Can you see it?
You're a little dark, but that's okay. That's okay.
So the topic which I want to cover today is, which has been my passion and for a very long time, since I came to NASA in 1964. I came to Marshall Space Flight Center as a postdoctoral fellow in the National Academy of Sciences, as told by Parnuja. And I had a great opportunity of working with Von Braun, the famous German scientist whose contribution to the city of Huntsville are great. Actually, the whole Huntsville city is, the research in this town and the many universities like UAH is his conception of starting the PhD program and others. And I really had a great opportunity of working very closely with him. Rather, I used to see him almost every month when I was a postdoc. And he came to a lot of my lectures and seminars which I gave. So you can imagine the scientist, what kind of scientist he was. Being a director of the Marshall Space Flight Center, he used to come to seminars in the department, and he told my director of the lab that whenever there is a seminar, I would like to come. So that was the caliber of the people. So today I will talk about two topics. One is basically the research ethics and the lab practice, which is very important not only for the students but faculty and everybody. That why should we? So in terms of research ethics, you see that different societies, different professional associations like government agencies, universities have adopted specific codes. And many different agencies like NSF have different codes, and the government, NASA and other agencies have codes and policies relating to research ethics. The code, the topic which I want, the points which I am going to discuss a little later here are the following is a general summary of some of the ethical principles cited by David Resnick of the National Institute for Environmental and Health Sciences from the NIH. Number one, which is always true, that honesty is very important in research, that one should strive for honesty in all scientific communications, reporting of data, results, methods, procedures, and publication status. So the honesty is very important. One can easily cheat. You take a data and you can write whatever you want to write. And I will discuss later on that how the data should be recorded. So that's really important. Do not fabricate, falsify, or misrepresent data. That is very critical. And there have been cases in the world where the scientists have been penalized and punished for doing that. There was a scientist at Harvard who actually reported some work which he did in a project with the DOE, and a similar work he reported to defense on a project, and it was caught. He was debarred by the federal government for receiving any federal grant for the next 10 years. So it is really important that one should not, he thought that nobody will know that I did this work for Army and I am doing this work for DOE. And so it is really critical. Do not deceive colleagues. This is also very critical that, people, you are working in a lab, you have access to all the labs, you can go to every department, every lab in this department, and you can see certain things which your other friends are doing, and then you can, so this is very critical that one should not deceive colleagues. Even the granting agency, the example which I gave you about deceiving the DOE and defense is because of that. You do not deceive granting agency or the public. Objectivity. Avoid bias in experimental design. Data analysis, peer review, personnel decisions, grant writing, and expect testimony and expert testimony. Avoid or minimize bias. One should not try to do any bias regarding data or any research basis. Disclose personal and financial interests that may affect research. A lot of time people do not realize that there are personal interests. Somebody may be interested, you have a friend in DOE or the NIH and you want to do or mention something, but that should not be done in research. One should avoid totally any personal, and if you have financial interest with a company, one should not be biased to doing any reporting of any data of that kind. Integrity, that is also very important. Keep your promises and agreements and act with sincerity and strive for consistency of thought and action, which is very obvious the way it is worded here. So one should not do that. Carefulness, this is also very important. Avoid careless errors and negligence. Carefully and critically examine your own work and the work of peers. That's very critical, important to analyze and critically examine your own work and the works of the peer. Keep good records of research activities. That is very, very important. You have to keep a good record, and I will later on show that what the record should be kept, how the record should be kept in a lab book. Such as data collection, research design, and correspondence with agencies or journals. One should be documenting all this in a very, very clear fashion in the notebook of some kind, and I'll talk of the notebook a little later. Openness. Be open to criticism and new ideas. When we do research in the lab, we ask the students, criticize the experiment. If you don't like the way I am suggesting or some professor is suggesting, you may have some good ideas to do this work in a different way or design an instrument in a different way, whatever. So be open to criticism and new ideas. Share data, results, ideas, tools and resources. This is a very critical term, that respect for the intellectual property. Honor patents, copyrights and other from intellectual property. If you are looking at something which is a patent, you have to refer that. You just cannot say that, oh, I did this work. That's not good. You will be caught in some time or the other. And it is really critical, I can give my one example. When I did my PhD, I used an instrument which was designed by somebody else. And I wrote very clearly in my thesis that this is the instrument I am using, but it was not written the examiner did not see it, and he was really mad on me. He wrote in my thesis comments that the such and such author forget to recognize the agency or some company who designed this piece of equipment. But luckily I was safe. I had written down and he missed that line in reading the thesis because it was 120 pages and he didn't read every single line, looks like. But it is critical. So do not use unpublished data. If you are using unpublished data, many times people do refer unpublished data in their thesis, and it should be mentioned very clearly, although they discourage using unpublished data. But sometimes people do have to use, on the permission of the author, the person who has done that work, and they clearly write unpublished work. But it is not a very good idea to use unpublished data in somebody's paper or whatever research. Unpublished data or the methods or results without the permission. If you have the permission of the person who has done that work, then it is okay. But if you are not, then you cannot just write. Give credit where credit is due, which is obvious. One should not do that. Give proper acknowledgements of credit for all contributions to research. Never pluralize. That is very important. Let me mention this, that although it's not written in this presentation here, but some agencies are now coming to a stage, especially the journals in the medical field, that they require you to write when you submit a paper for publication. If there are 4 authors, then the journal requires that when you submit a paper to publication, you must mention that the first author has done what work. Does he design the experiment? The second author has taken the data, for example, that is a student. The third author helped in interpreting the data, and the fourth author just reviewed the paper and made corrections and things like that. So it is some journals are doing that, and I won't be surprised that within the next 10 years, maybe every journal will require that. And that I feel is a great idea.